Okay, so yesterday we started talking about how can we find answers, how did we explore different libraries, and what are the data that available out there. And we kind of mentioned the Google Trends API. I just want to show you an example of how to deal with this kind of situation. Maybe like you never dealt with Google Trends API. You know, things keep changing. Even if you have some experience with some tools or some frameworks or some APIs, they keep changing. So a survival skill that you can search, you can navigate your way through the new information, or update your update what you know about things that you already experienced. So don't trust what you know, like only if it was a few months ago. You never know, it may have changed. Okay, things change very frequently. So you just you keep your mind agile. Okay, so let's say you want to learn about Google Trends API. All right, so I can see some resources here and there, and there's a collab. Remember when we mentioned about the different environments in which you can run Python code, and one of them was the notebook, right? That was the very first lecture in the semester. Okay, so you can see a lot of examples in notebooks that are available for public. So that sounds good because it means that there is example code. All right, so that's, if you find something like this, a notebook, that's a good place to start with. And then this is a tutorial. So, you know, in the notebook, you know, that sometimes you have cells of code and sometimes you have cells of text. So that makes it a good tool to create tutorials. Okay. So you can look here. How do they use it? What are the common use cases? Now, what I want to highlight here, okay, eventually we're going to get into the coding example of the implementation of this finding the trend setters. But before that, we need some preparation. For example, if you look here, in part of the tutorial, they mentioned pandas, which is a very, very popular library that used in machine learning and in data science in general. And the major data type there is the data frame. Okay, so so you may look at different APIs. Oftentimes you will see references to pandas, and sometimes you will see references to NumPy or NumPy. Both of them are very popular libraries. Okay, that's why we need to at least have an introduction, understand what they are about, and where to find more information if we need to. Okay, so that's just an introduction to today's lecture, which is an introduction to NumPy, and NumPy is one like important library that Panda's been built on. Okay, so just because we don't have an exam doesn't mean that you ignore this, because you're gonna need it. Even if the APIs I choose don't use NumPy, in the future, in the very near future, in other courses, in like whenever you need to work with machine learning or in data science, in projects in general, NumPy and Pandas are very important libraries. So that's why we need to cover them. So today we're gonna have an introduction to NumPy. And tomorrow we'll have an introduction to Pandas. Okay, so what is NumPy? So it's short for numerical Python. Are you taking a numerical analysis course that maybe this semester or previous semester, numerical analysis? Yeah, there is a course, numerical analysis course. Sorry? Computational? Maybe it has a different title, but you learn a numerical analysis. Everybody in engineering should learn about numerical analysis. I don't remember the title of the course. Statistics is very important too, but there is courses like prefixed NMM, numerical and mathematical methods, or something like that. Like you learn about matrices and the matrices, vectors and operations. Linear algebra is part of it. Okay, it's part of it. Linear algebra is not all that important part of it. So numerical Python has some libraries, some functionalities that help with numerical analysis, including linear algebra. Okay. Now, just a heads up, lots of. Okay, I'll tell you that next slide. Now, here's the central data type. Now, if you remember when we started learning about Python, we learned what are the major data types and what are the major operations that apply on these data types, right? So a good starting point when you're learning anything, any new library, to learn what is the major data type and what are the major operations, because everything builds on. So the major data type in NumPy is called an array or a multi-dimensional array. In Python, without NumPy, you can create an array, right? You can create a multi-dimensional array, right? What is the data type you can use in order to create multi-dimensional array without NumPy? With the basic types of Python. How can you create an array in Python? You know. Yeah, square brackets. Yeah, what is the data type? What is the name of the type that have list of data within square brackets? Yeah, list. Okay, so list is the basic data type in which you can create collections or you can create a form of array. Not the exact or a form of array, okay? Now, NumPy takes that list and builds on it. Now, you see, next time when we talk about pandas take what NumPy have and build on it, okay? So NumPy takes this basic list and add some efficiency measures and some additional operations that can be used in numerical analysis. All right, so the basic data type there is array, which is a more efficient and a more functional form of a list. Okay, now you can go to the link in which you can see. So this is the home page of the library. Now you can see there all types of information. Now, if you go to learn or go to documentation, a good place to start learning something new is usually there's something called start here or getting started. Okay, so if you go there, it will give you the most basic information and how to start, especially how to install. And they keep changing that. Okay, so it's not, last year there was -u for update. This -u is not present anymore. I mean, so you keep changing, everything changes. So keep your mind open for updates. All right, so how would you install a library? We know we can use pip install. Conda if you're using Anaconda, but we're not using it. So we can just open a terminal. So I'm gonna open a CMD, command terminal, anywhere, and I just say pip install NumPy. All right, I already have it installed, but just for you to see, okay, requirements already satisfied. But if you didn't have it installed, you will see the, the progression of the installation like here. All right. Now, in addition to the tutorials and the information that you can see on the homepage of the library, you can also, if it's open source, which most of the Python library are open source, so you can go to their GitHub repo and see the actual code of all the functions or the all the code that is available there in the library is right there for you. Okay, including links to the website and the documentation. Now that's a good place to contribute. If you have I mean, you can look into some. So if you go to NumPy, for example, here, and you're curious about something specific, so they redefine certain types, like car here, and okay, let's see something. Now I want to see how the array is defined, for example. If you go to core. Now you can see all the Python files here that constitute um, the contents of the library. Okay. All right, so you can keep searching. Let's just say numeric here. So this is one of the scripts that are available there. You can look into it, see if you can at least add documentation. If you find a bug, you can report it, or you can try to fix it. So open source contributions is a good thing that you put on your resume. The very basic thing of that you can contribute is just documentation. If you open this function, for example, you see there is no documentation at all. If you study it, learn it from other sources and add some documentation, you can try to submit it as a contribution and you can list it in your portfolio. Okay. Now, otherwise, if you don't want to contribute, it's good to have access to the source code. If something is not clear, didn't understand it from the documentation, you can go to the source code and look into it to try to understand it better. All right. Now, when we say NumPy API, so we talked about the concept of API before, but we talked about it in the sense of having API remote services like the ones we access through Google, for example. Okay. Now, the concept of API is more generic. It doesn't have to be in a remote sense. It doesn't have to be accessible through HTTP protocol like the ones that we have tried. Okay. Any set of functionalities, any third party, any code that you didn't write that is available for you to access can be called API. So now the set of functions that are available in NumPy are called NumPy APIs. Now these functions are a form the basics or the basis for a lot of libraries that are popular in machine learning and data science, including and especially the library called pandas, which we're going to talk about tomorrow. All right, so this is how you install it. And once you install it, you can import it. Now we know how to import, right? Now it is very common. What happened? It is very common that you use an alias for the library, so a short name, if you remember when we talked about modules, okay? A very popular alias for NumPy is NP. You can even sometimes you don't see the import line, but everybody knows that NP means NumPy. Okay. So this is the short of a NumPy. When we import it, we can use it to create the arrays. And the simplest form of an array is the one-dimensional array. Okay, which is pretty much the same as the list. So you can, you know, the NumPy array is built on top of a list. You can send it a list, and then they form the array on top of it, right? So you can send it. You can create an array based on the elements themselves, but it's much easier if you define the list like this and then send it, or just send it the list and the argument right away. Okay, so that will take the basic list and turn it into an ND array. So ND short for N for multiple. Okay, D for dimension. So multi-dimensional array.